In this problem, we need to find the Norton equivalent circuit with respect for the terminals A and B of the circuit. We know that our terminals are right here, and we need it to look like this diagram right here. This is the Norton equivalent. To do this, we are going to use the source transformation. When we use source transformation, we are going to look at this 15 amps and this 8 ohm resistor. We're going to transform this to have a voltage right here instead. And then our resistance, our 8 ohm resistor, is going to be here. On top of that, what we can do is, since these two resistors are in series, if a resistor is on top of another resistor, or if it's directly across from it and it's in the same kind of section, we can combine these to be in series. So this is actually going to be 12 ohms of resistance, and we can rewrite all of that after we find the voltage. So we know that our V of S is equal to I times resistance. We know that our I is 15 amps, so we're going to have 15 times our 8 ohm resistance. That's going to give us V of S is equal to 120 volts. And this is what we have now. We can, since our 8 ohm resistor and this 12 ohm resistor are in series, just combine them. So we get 20 ohms of resistance. Now we are going to have a 120 volts and then a 20 ohm resistor and then a 12 ohm resistor in parallel with that, and then our terminals A and B. Well, we can use source transformation again on this 120 volts and this 20 volts. And what we're going to do is we're going to change it. So instead we have a resistor that's 20 ohms, and then we have a current right here. To find our current, we know that we can use Ohm's law and set our current equal to voltage over resistance. We know that our voltage is 120, and we know that our resistance for it is 20 ohms. Doing this, we can see that our current is going to be equal to 6 amps. So I'm going to redraw this properly. In doing this, we can see that our 20 ohm resistor and our 12 ohm resistor are in parallel. So we're going to use the parallel formula for resistance in parallel. We have 1 over our first resistor plus 1 over our second resistor, and this is all being raised to the negative first power. If we set this equal, we are going to get 7.5. And we can see that this 7.5 is equivalent to this Rn right here. So we found our Rn. This is 7.5. We don't have anything else to the left of that other than our 6 amps right here. And our 6 amps is in the position of our I of n. So that means our current is 6 amps. And those are the answers for this problem. If you want more problems like this, there's a playlist linked below with an entire course of Introduction to Circuit Analysis. Also, there's notes in the description that'll help with this class or any exam for this class.